This video is meant to go along with your Chapter 1, Chapter 2 study guide. Yeah, I guess that's intro enough. Let's get ready for that test. So, first things first, memorize this. I'm not going to go through it now in this video. We went through it in class. Whatever way works for you, learn it and memorize it. Writing equations for the lines, a point or a line through the point 1, -6 with the slope parallel. Parallel has same slope, so it just says an equation. So let's use point slope since we have a point in the slope. Y plus 6 equals 3x minus 1. Remember, that's y minus y1 equals mx minus x1. A vertical line. Vertical lines will go through our x-axis. So that would be x equals 0. It's a little trick question there. A line that goes through those points. So first we need to find our slope, which will be 6 minus -2 over -3 minus 1, which is 8 over -4, which is -2. And then you pick a point and plug it in. So we can either have y minus 6 equals -2 x minus -3, so x plus 3, or we can have y plus 2 equals -2 x minus 1. Either one of those would work. Write an equation for the line with the slope perpendicular to -3 and a y-intercept at 3, so we have a slope and an intercept. That would be y equals, perpendicular means opposite reciprocal, 1/3 x plus 3. Number 3, describe the symmetry. If you graph this function, you will see that it does something a little like this, and that is symmetry about the y-axis. Determine whether a function is either odd or neither. Remember, if it's even and we plug a negative into our inputs, our output will stay the same. If it's odd and we plug a negative in, then our outputs will be different. So if I plugged in a negative x to the 4th power plus 1 over a negative x to the 3rd power minus 2 times -x, and we worked that out, we would still end up having x to the 4th on the top plus 1. On the bottom, we would have negative x to the 3rd plus 2x. And we work that out, we can make it look like our original function again, x to the 4th plus 1 over x to the 3rd minus 2x if we factor out that negative. And so we can see here that that is -y. So since it changed, that is an odd function. Find the domain and range and graph the function. So this one, yes, you asked if you could use a calculator, that's fine, but let's remember that form that we have, where first thing we have to get that x by itself by factoring out a 2, and when we do that, we'll get x plus pi over 2 in those parentheses minus 1. Our period is always this, let me change to a little pointer thing. This here is our b value, and that always equals 2 pi over the period. So 2 equals 2 pi over the period, which means our period is just pi. The number out in the front tells us our stretch or our shrink. So we have a 3 stretch. Right here tells us our shift, left or right, and we have a left shift of pi over 2. And this here tells us our shift up or down, and so we have a downshift of 1. So our sine curve usually starts at the origin right here. So we need to take that point and we're going to shift to the left pi over 2, and then we're going to shift down 1. That is going to be our new starting point. And it tells us that we will repeat, or our period will repeat every pi, so that means we will complete a complete sine curve every pi units. So I'm going to go ahead and at every pi point, I will make another dot. This tells me that I should complete a full sine curve within those. Because we're completing a full sine curve, that means that we will, half of the sine curve will be right here at these little blue dots. And now we need to figure out how high up and how high down we go. So if normally going from our starting point, we go up to 1, we're going to first multiply that by 3, which would be 3. And then we're going to subtract 1. We'd be back down to 2. Oops, I need my pen. So this would be our spot. And after each purple dot, we'll have another one. Because remember, we have a period of pi. Next, we need to look in the negative direction. If from our origin, the one behind it went down to -1, we need to multiply that by 3. So that would be -3. And then we have a shift down, so we would go all the way down to -4. And that is going to repeat every pi. We then have enough to draw in our wonderful, beautiful line, or curve, actually. And here we have graphed our sine function without the use of a calculator. Woohoo! It says find the domain and range. Our domain is going to be all real numbers, not -8, from negative infinity to infinity. And our range is going to be from -4 to 2, inclusive. Find f of g of 2 if f of x equals that and g of x equals that. So f of g of 2 means we're going to take the function f and we're going to plug g into it, and then we're going to plug 2 into g. So this is 1 over the square root of x plus 2. So this is 1 over the square root of 4, which is 1 over 2, which is 1 times 2, which is 2. Find the 6 trigonometric values of theta equals the inverse cosine of 3 over 7. So let's remember, if we're looking at a right triangle, cosine is going to give us adjacent and hypotenuse. So if we say that this is theta, the adjacent side would be 3, the hypotenuse would be 7, and we need to figure out our opposite side here. So according to Pythagorean's theorem, we know that x equals the square root of 49 minus 9. So x equals the square root of 40, or x equals 2 times the square root of 10. Now we can go through and do all of our trig values. The sine of theta, that's opposite over hypotenuse, 2 square root of 10 over 7. Cosine theta, opposite or adjacent over hypotenuse, is 3 over 7. Tangent of theta is opposite over adjacent, so that's 2 square root of 10 over 3. cosecant, that is going to be, remember we will flip the sign, but we can't have radicals in our denominator, so we'll get 7 the square root of 10 over 20. For secant of theta, again we'll flip it, we'll have 7 over 3. And for cotangent of theta, again we want the reciprocal, we can't have square roots in the denominator, so we can't have 3 over 2 square root of 10, so we'll multiply the top and bottom by the square root of 10. We'll get 3 square root of 10 over 20. Now solve for x. We have e to the negative 0.2x power equals 4. The inverse of e is the natural log, so if we take the natural log of both sides, those two will cancel out and we will get negative 0.2x equals the natural log of 4. You can solve that out, plug it in your calculator, and we will get that x equals negative 6.931. If Rafiki invests $1,500 in a savings account in Simba's education, this particular type of account earns 8% interest compounded annually. How long will it take for the single payment to grow? $5,000. So, since we have a certain amount of time, our compound interest formula is y equals 1 plus r over n to the nt power. When we plug everything in, we'll get 5,000 because that's what we're looking for, equals our initial, which is 1,500, times 1 plus our rate, but we need to write it as a decimal, so that'd be 0.08 over 1, to the nt. N is the number of times that it's compounded per year, that's once, and t is the amount of time in years. We need to solve for t. So if we divided by 1,500 on both sides, we would get 3.33333333 equals 1.08 to the t power. We need to go ahead and try to solve for t. Remember, our rules of logarithms tell us that if we take the natural log of something with a power, we can bring that power down to the front. So when we do that, we will have the natural log of 3.33 equals t times the natural log, remember we can bring that t out to the front, of 1.08. Once we do that, we can divide the natural log of 3.33 by the natural log of 1.08, and we will get t equals 15.5. But since it's only compounded once per year, that means it will be compounded, or we will reach that amount of 5,000 in 16 years because we need that full year. Time for limits. So first we look across our limit and see if there's any domain errors or any restrictions on the domain. Here in this polynomial there's no restrictions, so we can just plug in negative 2. Negative 2 cubed minus 2 times negative 2 squared plus 1. That gives us negative 2 times negative 2 times negative 2 is negative 8. Minus 2 times 4 plus 1. That gives us negative 8 minus 8 plus 1, which equals negative 15. Next, we check, do we have any errors in our domain? Well, we know that we can't have a negative number, but let's see what happens when we plug 4 in. Minus 2 times 4, and that gives us the square root of 1 minus 8 equals the square root of negative 7. So obviously that limit doesn't exist. If we plugged a 5 in and we were coming from the positive side of x, we would come in and still we wouldn't be able to get anything. 4.01, 4.02, 4.03, none of those exist. If we plugged in things from the negative side, 3.9999999, those still don't exist. So here our limit does not exist. And that's because our domain is only from negative infinity. I keep writing -8. Negative infinity to 1/2. Anything greater than 1/2 does not work at all, so there cannot even be a limit. Now over here, let's test it by plugging in some things. We get 2 plus 0 minus 1/2 over 0, which ends up getting us 1/2 minus 1/2, which is 0 over 0. Since it's a positive 0 over 0, that is indeterminate, which means that we need to do some algebra. So when we do some algebra, let's go ahead and let's get rid of this fraction. I'm going to multiply by 1 over x instead of dividing by x. So that is 1 over 2 plus x minus 1 over 2 times 1 over x. And when we do that, we end up with 1 over x times 2 plus x, because we're distributing that x, minus 1 over x times 2. And remember, again, we are distributing that x to each denominator. When we want to combine like terms, we see that each one has an x as a factor. This factor is just missing x plus 2, and this factor is just missing 2. So we will go ahead and do some like denominatoring. This one needs to be multiplied by 2 over 2, and this one needs to be multiplied by 2 plus x over 2 plus x. When we do that, we get 2 minus 2 minus x over 2x times 2 plus x. Work that out again, and we get negative x over 2x times 2 plus x. Some fruit ninja-ing here. X and x cancel out, and we have negative 1 over 2 times 2 plus x. Can we now plug 0 in? Yes, we can, and when we do that, we get negative 1 over 2 times 2 plus 0, which is negative 1/4. Alright, here we go, some more. We're talking about infinity now. Infinity to the 4th power plus infinity to the 3rd power. Remember, when we have polynomials, we really only need to focus on our end behavior models. So we end up with x to the 4th over 12x to the 3rd. X to the 3rd will cancel out. X to the 4th will just become x. And we have x over 12, or infinity divided by 12. Infinity divided by 12 will just be infinity. Now we need to look at negative infinity. Same thing, we'll just check out our end behavior models. It will still reduce to x over 12. When we plug negative infinity in, we will get negative infinity divided by 12, which will be negative infinity. Down here we have the limit as x approaches 0 of sine of 2x over 4x. This is like saying sine of 2x times 2 times 2x, right? Remember that wonderful little property that told us that sine of 2x over 2x equals 1? So this is like 1/2 times 1, which is just 1/2. Now, we need to make sure that every time we're doing this, even if we're looking at in behavior models, that we're not messing up our domain by plugging in the number. On number 16, even though we'd be tempted to just look at in behavior models, we first need to check to see if going to 3 messes up our domain. And sure enough, it does, because we can't have zeros in the denominator. So we need to factor. The top is going to factor to be x minus 3, x plus 1, over x minus 3. Do some fruit ninjaing there. And we have x plus 1. When we plug in 3 into that, we will get 4. Now, the limit as x approaches 3 from the negative side, we look and see if there's any factoring we could do. We could factor out an x, which would get us x squared minus 2 over x minus 3. And really, that's all we can do. So let's see if we can think about this in terms of limits. If we were to plug in 2.999999999, because that's approaching 3 from the left side, we would end up getting a negative 0 in our denominator. We would get really, really close to 0, but it would be coming from that negative side. Up top, if we plugged 3 in, we would get 3 times 9 minus 2, which is 21. 21 divided by a negative 0 would be a negative infinity. Checking out number 18, coming from 0 on the positive side. First, I'm going to check out my factoring, see if there's anything I can do. X plus 1 times x minus 1 over x. Sure enough, nothing. So I want to see what is going to happen if I plug in a number like 0.000001, because we're coming from that positive side. So if we do that, we'd end up with 1 times negative 1, which is negative 1, divided by a positive 0. Negative divided by positive is going to be negative, which is negative infinity. Now we need to check out number 19 again. I think it's very important to first just check our factoring, see what we get. When we do that, we will get x plus 1 times x plus 2 over x plus 1 times x minus 1. Put ninja those out, and we get x plus 2 over x minus 1. Now, we are coming from 1 from the positive side, so if we're coming to 1 from the positive side, that would be like 1.000001, which means at top we would have 3, on the bottom we would be very, very, very close to 0 from the positive side. 3 divided by 0 from the positive side would be positive infinity. When do you get a vertical asymptote and when do you get a horizontal asymptote? Remember that x equals a is a horizontal asymptote, vertical asymptote, if the limit as we approach a certain number is either positive or negative infinity, whenever there's inbounded behavior or when you're dividing by 0. Then a horizontal asymptote happens if you're approaching infinity and your limit actually equals a number. So the limit as x approaches infinity equals c. You can look at the study guide key if you need more of a written explanation. Illustrate the 4 types. We have removable, which is a whole. We have non-removable. These are all non-removable. There's jump, which is when you go from one line to another with no connection. There is unbounded, and that's when you get asymptotes. And then there is oscillating, and that's when a function starts oscillating so much that we have no idea what's going on in the middle. Answer the questions for the piecewise defined function. Find the right and left-handed limit. So the right-handed limit is as it comes from the numbers that are larger than 1. So when x is greater than or equal to 1, we'll plug that in. That's 1 squared minus 2 times 1, which is negative 2, minus 2, which will give us negative 3. For our left-handed limit, those are the numbers less than 1. We plug in 1, the absolute value of 1 minus 4. That's the absolute value of negative 3, which just equals 3. Does x have a limit as x approaches 1? Sorry. Does f have a limit as x approaches 1? If so, what is it? If not, why not? So, no, because the left and right-handed limits do not meet. At what point is f continuous? It is continuous from negative infinity to 1, and from 1 to infinity. It's not continuous at 1. So what point is f discontinuous? f of x is discontinuous at x equals 1. Checking for some discontinuity, let's go ahead and first start off by doing some factoring. We get x plus 5 times x minus 3 over x minus 2, x minus 3. So, where are we discontinuous? We are discontinuous at x equals 2 and x equals 3. Now we need to classify them. X minus 3 can cancel out, so that means that x equals 3 is removable. And x equals 2 will give us a situation where we're dividing by 0, so that means it's an asymptote or unbounded. Give a formula for the extended function that is continuous at the indicated point. So we know we can't plug in 9 because we'd be dividing by 0. Remember, in order to get rid of these things, we will multiply by the conjugate. Hopefully this is becoming second-hand nature to me. So when we go through and do that, we will get x minus 9 times the square root of x plus 3 over square root of x times square root of x is x, negative 3 square root of x times 3, or plus 3 square root of x is just going to be 0, minus 9. Then we get front ninja that baby out, and we get the square root of x plus 3. So, when we plug 9 in, that's the square root of 9 plus 3, which equals 6. So our new little piecewise function formula to make this continuous is f of x equals x minus 9 over the square root of x minus 3 when x is not equal to 9, and square root of x plus 3 or 6 when x does equal 9. For response, explain why you can interchangeably evaluate the following. Make sure that your answer has something to do with the fact that they equal the same thing. When you approach 0, 1 over x, positive or negative side, you're going to get infinity, and when you approach infinity from positive or negative side, you're going to get infinity. So make sure your answer is somewhere along that line. Just curious. And that's the end of this video. I know it was long. I hope it was helpful. Joke of the day. So 2 muffins are in the oven, and one muffin looks over at the other and goes, "Man, it's hot in here." The other muffin looks at him and goes, "Oh my gosh, it's a talking muffin!" Ha 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 ha.